Greetings, math fans. All right, so this is our 438 Trig first semester review. All right, so I'm going to go pretty quickly through this. So maybe you get a couple tips here, but let's go. All right, so the first problem, if cotangent of x is negative 5 over 12 and x is between 0 and 80. So, I always told you guys, draw a picture, right? It's going to be in the first two quadrants here, right? And cotangent is negative, so we're going to draw our triangle here. And cotangent is the xy, so it's x over y. So it's negative 5 and 12 and 13. Okay, and then of course so cosine is x over r, so it's going to be negative 5/13. Okay, pretty easy. Next one, again, sketching a picture. First of all, it's between pi and 2 pi, so we're going to be in these two quadrants here. And secant goes with cosine, is reciprocal, so cosine is x over r, so that's r over x. And it's also positive. So we know we're in this quadrant here. Guys, got to get your signs right, because multiple choice is going to try and mess you up with signs, and you just got to know what quadrant you're drawing it in. So we said it's r over x, so this is 6 and 5, and then this is going to be square root of 11. So again, you guys can do the calculations, but that's square root of 11. Of course, that's negative, very, very important. And so they ask you cosecant. Cosecant is same as the reciprocal of sine. Sine is y over r. So this is r over y, so it's negative r 6. So then write this 6 over negative root 11. And if you rationalize that, you get negative 6 root 11 over 11. Okay. Secant of 7 pi over 6. Again, this is kind of just knowing your radians. This is all non-calculator, of course, this part that I'm doing now. And then we'll get to some calculator stuff later. But secant of 7 pi over 6. So reference angle is pi over 6 or 30 degrees. Cosine, so this is how my mind works, so maybe yours works a little bit differently. But anyway, cosine of 30 is root 3 over 2, so you flip it, it's 2 root 3 over 3, so 2 root 3 over 3, right? But 7 pi over 6 is here, so that makes it negative. Okay? Cotangent of 225, so it's a 45-degree angle, and cotangent of 45 is 1. So, of course, cotangent is the same thing there, right, is 1. And 225 over here. So then, of course, it's positive 1. Okay. All right, convert 240 to radians. Again, that's a really easy problem. So 240, and it's pi over 180. So basically, however you want to do this, cancel that out. And it's 24 over 18, which is just 4 pi over 3. Right? That's the way I kind of do the problem. Okay, and convert 11 pi over 12 to degrees, so same thing, it's going to be 180 over pi, so the pi's cancel, it's very sad. And you can do the 12, that's a 1, and that's 15, so 15 times 11 is 165. Okay, pretty easy. The terminal side of theta passes through negative 5, 5. So again, this is kind of sketching a picture here, and it's negative 5, 5, so we're down here. So 5, 5, and it's going to be 5 root 2, of course. We'll put the negatives here just to be good. And then you just basically just say what sine is. And of course, sine is y over r. So it's negative 5 over 5 root 2, which is negative 1 over root 2, which is, if I rationalize that, it is negative root 2 over 2. Okay? So it's pretty easy. Which of the following is not an identity? Of course, tangent is equal to 1 over cotangent. That's pretty obvious. 1 over sine is cosecant. That's obvious. Sine over cosine is not cotangent. It's tangent. So this is the one that is not an identity. And of course, d tangent squared plus 1 is secant squared. So those are all your Pythagorean identities. Definitely know your identities. Very, very important. Okay. Number 9, find an angle between 0 and 360 that is coterminal with 1,000. So basically, you're just subtracting 2 360s, so subtract 720, and you get 280. So be careful. This is just saying find an angle. If I said find a reference angle, then you would actually say, because your 280 is right here, you would say 360 minus 280, which gives you 80 degrees. That would be a reference angle, but I'm not asking you for that. I'm just asking you for an angle. Okay? All right, so let's keep going here. So here we go. Find a reference angle. This should look a little bit further. So basically, I'm going to add, just think about it. If I add 360 times 2. So if I add 720, right, I get negative 65. But really, again, I could add another 360. But think about it. If I'm at negative 65, isn't that my reference angle? 65 degrees. So that's the answer. 65. Okay, pretty reasonable. Cotangent of 1050. So again, you got to do coterminal, and if you do that, you get cotangent of 330, second favorite time of the day, and then cotangent 330. So we're down here. Reference angle is 30, and just to kind of put everything in here, and this is 1 and 2 and root 3, and of course this one's negative, and so cotangent is the xy, x over y, so it's root 3 over negative 1 or negative root 3. Okay. And tangent of 1050, again, it's tangent 330, so reference angle is still 30 degrees, and you guys should know tangent of 330. Woo! It's a three-party. Okay, and then, but of course it's negative because we're still in that quadrant, so that would be negative root 3 over 3. Okay. This is a good calculator problem, so just make sure you know how to put it in your calculator. Please do not type in sine. This is bad. I'm going to write this out, but don't do this. This is horrible, horrible, horrible. That's saying sine of 1/71st of a degree. That's bad. That's going to give you something like 0.000001, because what's sine of 0? Sine of 0 is 0. So sine of something really small to 0 is something really close. That's bad. Okay, so that you're really going to say 1 over sine of 71/28. Okay, and that should give you 1.055. Okay, cool. Write the period for each of these. You guys should know all of these. Right, these two are 2 pi. That's pretty easy. These are just pi, where tangent, remember, is when I have you set that up, that compound inequality, I have you set it up between negative pi over 2 and pi over 2. Cotangent is between 0 and pi. Secant is the same as sine and cosine, so that's 2 pi. Okay, so now we get to, if I ask you for the period for this one, remember that 3 is, of course, is your amplitude, so I'm going to say 6x is between 0 and 2 pi. Divide by 6, so 0 less than or equal to x less than or equal to pi over 3, and so the period is pi over 3 minus 0, or just pi over 3. Okay, this one, 2/3 x, so 2/3 x is between 0 and 2 pi. Multiply everything by 3/2, so you get 0 less than or equal to x less than or equal to what's going to give us 3 pi, right? So what is the period? The period is 3 pi. Okay. What is the amplitude for this problem? You guys better not say -2. It is +2. Okay. Let's keep going here. Write the phase shift and the vertical shift along with the direction for the following. Okay, so the vertical shift is super easy. Now this is put at the end of it, so just be careful. So the vertical shift, of course, is down 1, and the vertical shift here is up 1. Pretty easy. Okay, and as far as the phase shift, remember what I kind of told you to do. There are 2 ways to do these problems, and if you guys remember, I can either set it equal to 0, set that 3x plus pi over 2 equal to 0, or I can set up a compound inequality. Okay, now if it was tangent, you have to set it equal to 0. So it's not really a bad way to find out the phase shift. So if I do 3x plus pi over 2 equals 0, so I'm going to move that over, so I get 3x equals negative pi over 2. And multiplied by 1/3. So x is negative pi over 6. So that's my phase shift for the first one. Pretty easy. And then this one is x minus pi over 3 equals 0. So add pi over 3. So my phase shift for this one is pi over 3. Okay, so that's a pretty easy way to figure out a phase shift. Number 16, you should be able to write equations given graphs. I kind of showed you a good way to do that back in the day. Basically, with your compound inequality, I think it really is easy. Yeah, so let's set this up here, right? First of all, I'm going to look at this as a negative sine graph. Okay, so that just kind of helps me out a little bit, and it's going between 0 and pi. So remember, I want this to be 2 pi, or 2x, sorry. I want this to be 2 pi. Okay, so get rid of that. So I want that to be 2 pi. So that means I'm going to multiply this whole thing by 2, and I get this, 0 less than or equal to 2x less than or equal to 2 pi. So that's part of the equation, which is kind of nice. Let me move this down just a little bit. So I'm going to get y is equal to, and by the way, the amplitude is 2, and it's a negative, so it's negative 2 sine of 2x. Okay, so that's pretty easy. And then this one, you kind of need to sketch a little bit here. First of all, I can tell that is a shift. See that? There's a shift there, so I know it's going to be a +1. And I can tell you it's either going to be a cosecant graph or a secant graph. So if let me make this in red here. So this is kind of what my graph looks like here. And you can kind of tell let's just call it's a sine graph, right? If you starting here and it's going up and it's shifted up. So what I want to really do is find my sine graph. And if you look at it, it's between negative pi and pi, so the period's 2. So there's actually nothing fancy about it. So my sine graph would be y is equal to sine of x plus 1, right? Because it's vertical shift of 1. So that means this problem is going to be y is equal to cosecant of x plus 1. That's all it is. Just be careful though, because you're so into look at the dotted line, the red dotted line that I just drew, and you're like, oh, y equals sine of x, and that's what you put on the answer blank. Where truly you're just using that to figure out what the graph is. Okay. All right, coming along here, math fans. This next one is it's a cotangent graph, and you guys should remember a cotangent graph is between 0 and pi. Okay, just for if it was one no different period, right? So I'm going to draw. Here's a dotted line here between 0 and pi, and I showed you how to do this back in the day. The amplitude is, which doesn't really have an amplitude, but the value of a is 0.5. So we're going to kind of put a little dot there. And remember, guys, I showed you that with remembering all students take calculus. So if you think about it, all students take calculus, but you can use that for cosine. So cosine goes this way. It starts in this quadrant, and tangent starts in this quadrant because all students T, right? The T and then the C. So I know it starts down here, and if I put a couple more marks here, let me put this in a different color. There's that point, and there's that point. So this is what my graph looks like. This is a positive cotangent graph. Okay, between 0 and pi. All right, then of course it can extend out the whole thing. It's periodic, so draw another dotted line, and you could draw a few more graphs, whatever. I think I had that on my answer key, several graphs. Okay. All right, so okay, moving on here. Write the domain and range for y equals cosine of x. So domain for cosine is easy, right? Y equals cosine of x. The domain, of course, is negative infinity to positive infinity. And the range for just a amplitude of 1, it's just going to be negative 1 to 1, right? That's pretty easy. Okay, and then cosecant is a little bit different. Just remember, it goes with sine, and since you have a little bit of issue with the domain. So we'll do the domain first. Okay. So y equals cosecant of x. So the domain for this one is going to be basically, think where it's undefined. Do you guys agree it's undefined at whenever sine is equal to 0? So it's 0, pi, 2 pi, 3 pi, etc. So it's basically the domain is going to be x. First of all, it's all real numbers. So I'm going to say, put this in good form here. So x such that x is not equal to k pi. And k is an integer. K is an integer. Okay? So that is the domain, because you can do everything but wherever it's equal to pi. And then the range is, think about it, it goes, a sine graph is negative 1 and positive 1, so the range for a cosecant graph is negative infinity to negative 1, including negative 1, union 1 to infinity. Okay, so that's your range. Okay, so write an equation for one of the asymptotes of y equals tangent of x. It's a very polite function. You're welcome. So that's pretty easy. You just have to think, again, where is tangent undefined? It's undefined at pi over 2, right? So there we go. X equals pi over 2. X equals 3 pi over 2. X equals negative pi over 2. All right, that's cool. It's pretty easy. Simplify cosine of pi over 2 plus x. So you basically, for this one, it's remembering cosine of a plus b. So you have to know your identities. Very important. Okay, so if you remember, it's cosine a, cosine b, and then it's opposite sign, minus sine a, sine b. So if you plug it in, we get cosine of pi over 2, cosine of x, minus sine of pi over 2, sine of x. Okay, cosine of pi over 2 is 0. So it's 0. So that gets rid of the whole thing there. And sine of pi over 2 is 1. So it's negative 1 or negative sine of x. That's actually, it's simplified. Okay, not bad. We're still going along here. 2122 says round lengths to the nearest hundredth and angles to the nearest minute. Okay, so the first one's like a really easy problem because that is just right triangle trig. I'm looking for x, so basically I'm using cosine because cosine is adjacent over hypotenuse. So cosine of 52 degrees, of course being a calculator problem, is equal to x over 20, cross multiply, and x comes out to be 12.31 centimeters. Okay, this one is not a right triangle, so you basically think what I have here. I have an opposite side angle relationship, and here's another side angle relationship, so this is definitely law of sines. And the only thing there's a risk here is, notice I have angle side side. All right, that I could have two answers. Okay, so I don't really have a lot of room to write this in here, but basically here, let's just do the first one. I have 12 over sine of 18 is equal to 14 over sine of x. So you solve for x, and x is, I'm just going to do 21 degrees. 21 degrees, 8 minutes. 21 degrees, 8 minutes. Okay, so in order to find out if there's a second triangle, remember you do 180 minus 18 minus 21. Okay, and that, so that's what, 39, so 141, I believe. Okay, so 141, and that's, so I have a second triangle here. So my second triangle is, this is certainly not my second triangle. I'm going to cross it off. That's just the check, right? My second triangle is 180 minus 21, which is like 159 degrees. That's my other possible x. So just be careful about that. I mean, we spent a lot of time on that, and I went crazy with all this stuff. I'm saying don't swear and blah, blah, blah. But you guys should know, if it's an angle side side that's given, you should know to check for a second triangle. Super important. Okay? All right, so this next one, I'm basically giving you three angles, right? So this is angle side angle, and so you know this next one is 87 degrees, and this is law of sines, but it's not an ambiguous case. So it's going to be 24 over sine of 87 equals x over sine of 51. So x comes out to be 18.68 centimeters. Okay, so hopefully you guys are good to go. I don't know if I'm spending too much time on problems, but it's what it is. Okay, so we have two area formulas, which you definitely need to know. You definitely need to know Heron's formula, and you need to know that other one, area equals 1/2 AB sine of C. Okay, got to know those two formulas. So in this case here, I'm giving you three sides. Of course, we're using Heron's formula. So again, just to kind of go quickly so I don't bore everybody, get the semi-perimeter, which is all those added together divided by 2, and that's 37. And then the area is the square root of 37 times 37 minus 21, 37 minus 27, and 37 minus 26. Okay, so don't forget to take the square root, and we have 255.19 centimeters. Okay, pretty easy. And they ask you to find the measure of angle D. So they're asking you to find, oh, I'll just write this as, well, capital D. So that's what we're looking for. Okay, and so if you're given three sides, you're definitely using the law of cosines. So we're going to say d squared is equal to e squared, so 20. Oh wait, what am I doing? I'm finding the angle. So, but that's okay. Okay, so we need to write that out here because we're looking for angle d. So d squared, I'm going to write it out first because remember I told you back in the day, solve for the angle first and then plug it in. So d squared equals e squared plus f squared minus 2 times ef cosine of d. So I move things over, negative 2 ef cosine of d is equal to d squared minus e squared minus f squared, and then divide both sides by negative 2 ef. And then you substitute everything in. Okay. The only thing I can tell you is be careful is don't forget parentheses, guys. This is like super important. And then don't forget to take the inverse cosine. Okay. So again, I'm not going to show everything, but it comes out to be 69 degrees, 11 minutes. Okay. All right. This video is already 21 minutes, but that's okay. As long as my program does not die out on me, I will be happy. Because if it dies out on me, you'll hear a scream from your house because I will be screaming. Okay. This one's pretty easy. If the diagonal of a parallelogram measures 40 centimeters and the angle opposite the diagonal is 50, 11. So let's just draw a parallelogram. Okay, so the diagonal, it doesn't really matter how we draw the diagonal. We'll draw it that way because that's the way I have it on my answer key. So this is 24 centimeters, and this is the diagonal is 40 centimeters, and the angle opposite the diagonal is 50, 11. So 50, 11. Okay, find the other side of the parallelogram. All right, so again, this is really pretty easy to do this, right? You're basically looking at the triangle, right? So here, let me just draw the triangle. Okay, so we have angle side side. Okay, so let's take a look at what we got here. Okay, so I'm going to find this angle first. I'm going to call this angle A here. Okay, because basically it's ambiguous case, right? This is another angle side side problem. Okay, so it's ambiguous case. So what I'm going to do is law of sines. So I'm going to say sine of 50, 11 over 40 equals sine of A. I inverted it. That's okay. It doesn't matter. Sine of A over 24. Okay, and then you solve for A. A comes out to be roughly 27 degrees. Okay, and what are they asking? One side. Find the other side. So now we're going to do law of, once we know this A is 27 degrees. Okay, and we're trying to find the other side. So we're trying to find x here. Okay, so 50, 11, and 27. That's going to be 102, roughly 102. I know I'm rounding. 102 degrees, and then you use law of sines to find that. Okay, so this is just like a regular angle side side problem. So again, it's going to be, I'm running out of room here. Sine of 50 degrees over 40 is equal to sine of 102 over x. So x comes out to be 50.87 centimeters. So now the only thing I need to do is I need to check for the second triangle. Remember, the first thing you're going to do is you're going to check that this A. So we got A is 27 degrees, and so we're going to do 180 minus 27, which is 153, and then you're going to take that 153 and you're going to add the given angle to that, and you can see that's like 203 degrees, so it has no second triangle, so it just has one answer. And of course my final answer then is, I'm asking you for the side, so it's this guy here, 50.87. Okay? Okay. I just haven't done this worksheet in a while, so it just takes me, I got to kind of look at it a little bit. All right, so number 24, if the direction angle of a vector is 100 degrees and the direction angle of a vector is 60, a different vector, and I'm giving you the two magnitudes, just find the magnitude of the resultant of A and C. So this is really just drawing a parallelogram, guys. It really is not difficult. One is magnitude of 8, and the other is magnitude of 13. and I'm just going to draw a parallelogram because truly I just need the angle between them, which is 100 minus 60 or 40 degrees. So this is 40 degrees, and there's my resultant. And so, you know, it basically reduces the law of cosine. So this is 13 over here, and that's 180 minus 40, which is 140 here. And so you basically just say x squared is equal to 8 squared plus 13 squared minus 2 times 8 times 13 cosine of 140. Don't forget to take the square root, and x comes out to be 19.81 in units. No, guess not. Okay, 19.81. Okay, pretty easy. Okay, number 25, write in terms of sine and cosine, then simplify. Of course, sine of 2x is 2 sine of x. Cosine of x, secant is 1 over cosine of x. So cosines cancel, and you have 2 sine of x. Pretty easy. This one you got to get a common denominator basically, so I'm going to multiply this guy by sine of x minus 1 over sine of x minus 1, and this by sine of x plus 1 over sine of x plus 1. So you do that, and you get on top sine of x minus 1 minus in parentheses, so it's, don't forget to distribute that. So minus 1, or minus, let's do minus sine of x minus 1. Are we good with that? Yeah. Okay. And so then divided by basically sine squared of x minus 1. And the signs cancel, so you wind up just getting negative 2. And then you guys should recognize this is not cosine squared of x. Again, if you need to write it out, it's actually negative cosine squared of x. Okay, and then I can move that, the negatives cancel. I can move that cosine squared on top, so I get 2 secant squared of x. Okay, pretty reasonable. Okay, moving on. Okay, so now they're saying it's between pi and 2 pi. So we're here. Cosine is negative, so we're definitely in this quadrant here. Cosine is y over, or x over r, so it's negative 5, 13, and this is negative 12. So tangent would be y over x, so it's 12 over 5, right? Positive because it's double negative. And so that's squared plus 1. So it's pretty easy. So it's really 144 over 25 plus 25 over 25, which is 1, which gives us 169 over 25. Yep. All right, cool. Next one, I'm telling you it's between 0 and, or pi and 2 pi. So again, oh, we got two different pictures here, so I can draw one over here. So this is between pi and 2 pi, and cosine's negative, so definitely we're in this quadrant here. And cosine is x over r, so negative 3, 5, and this is negative 4. And then the other one is between 0 and pi, and cosine's positive, so we got to be in the first quadrant. So this is 12, 13, and 5. Okay, so this is for w, and this is for x. All right? And then we just need to kind of put everything together here. The first one is cosine of 2x, so we're using the one on the left. Of course, I would personally use 2 cosine squared of x minus 1, just because I'm giving you x, and if I mess up the triangle, I'd still get it right. So, of course, cosine is negative 3/5, so it's 2 times negative 3/5 squared minus 1. So 2 times 9 over 25 minus 1, or 18 over 25 minus 1, or negative 7 over 25. Okay. Sine of 2x is 2 sine of x. Cosine of x, so again, you're just substituting in. So sine of x is y over r, so negative 4/5, and cosine of x is x over r, so negative 3/5. So we get positive 24 over 25. Okay. C, again, you got that x plus w, so I'm going to rewrite it here. It's cosine of x, cosine of w, and then opposite sign minus sine of x, sine of w. So you're just pulling everything off of the triangles. So cosine of x is negative 3/5. Cosine of w is 12 over 13. Sine of x is negative 4/5. And sine of w is 5/13. Denominator should be the same. If they're not, you did something wrong. So that gives us negative 36 plus 20 over 65. So that gives us negative 16 over 65. Okay? And then this is sine of x minus w, so that's equal to sine of x cosine of w, and then it's same sign minus cosine of x sine of w. So sine of x is negative 4/5. Cosine of w is 12/13. Cosine of x is negative 3/5. And sine of w is 5 over 12, or 5 over 13. Okay, same denominator, which is good. So we get negative 48 plus 15 over 65. So that gives us negative 33 over 65. Okay. These are inverse trig functions, guys. Remember, it's got to be in range. You got to remember that. Okay. And here's quickly the range chart. Right. It's these two quadrants for sine 1 over sine, which is cosecant, and sine over cosine, which is tangent. And then these two quadrants is for cosine, or 1 over cosine, which is secant, or cosine over sine, which is cotangent. Okay, and this quadrant is never used. And by the way, this is negative pi over 2. This is 0, this is pi over 2, and this is pi. Okay? So anyway, arc sine of negative 1/2, you're saying the sine of what is negative 1/2? Of course, we're in the fourth quadrant, and the reference angle is pi over 6, and because you're in the fourth quadrant, it's negative pi over 6. Okay, so if you're confused about some of this stuff, watch the LOL again and refresh your brains about inverse trig functions, all right? Or do that. Remember that one worksheet that I gave you with like the 45 questions, different types of problems? That's a really good review too. Cosine's negative in the second quadrant, and the reference angle is pi over 3, so that's 2 pi over 3. So this is arc cosecant of the secant of 2 pi over 3. So basically what you need to do is, excuse me, you need to figure out what the secant, because these are different. It's cosecant and secant, so you can't just do it really fast. You have to say the secant of 2 pi over 3. So it's secant of 60, right? Which is think of the cosine of 60. So let's draw 2 pi over 3 over here. So it's cosine of 60 is 1/2, but it's negative. So it's negative 1/2, but it's a reciprocal. So this is actually negative 2. So really we have the arc cosecant of negative 2. Okay, so then I'm going to write, now I got to do the arc cosecant. I'm not really good with that, so I'm going to change this to arc sine of negative 1/2. Well, I know I'm in the fourth quadrant. Sine of what is 1/2? You guys should say, oh, it's 30 degrees, so pi over 6. And since we're in the fourth quadrant, the answer then is negative pi over 6. Okay? And the last one is the one where you, remember the arc's on the inside, so you'd make a picture, and it's the cosine, so it's the cosine of some angle that I'll never know. So if I draw it, our cotangent, you should be drawing it in this quadrant. Cotangent is x over y, so negative 8 and 3. And if I use the Pythagorean theorem, this is root 73. So cosine is x over r, so negative 8 over root 73. And I rationalize that. It's a little crazy, but it's negative 8 root 73 over 73. Okay? Which of the following have range values in quadrants 1 and 2? Well, we just actually talked about that, right? B and anything that has to do with cosine. So cosine 1 over cosine and cosine over sine. So those two. Those three. Okay. Humming along here. Which of A through F and number 29 have a range of values in quadrants 1 and 4? Oh, well, it's just from the back one. So it's A, C, and F. So that's, of course, sine 1 over cosine, which is cosecant, and sine over cosine, which is tangent. Okay? Pretty easy. The next one, these are solving equations, so you guys need to be good at that. If you see a cosine of 2x, please do not factor something out. Ugh. If you factor something out, you're going to get punched. Okay, you have to change cosine of 2x into one of the identities because it's already in terms of cosine. We're going to change that to 2 cosine squared of x minus 1. Okay, very important. Minus 5 cosine of x equals 1. Distribute that, so we get 6 cosine squared of x minus 3 minus 5 cosine of x equals 1. I'm going to move everything over and rearrange it. So I get 6 cosine squared of x minus 5 cosine of x minus 4 equals 0. Okay, and if you factor this baby, you get 2 cosine of x plus 1. You can use your factor cylinders or factor cubicles or factor boxes, whatever, I don't care. And then 3 cosine of x minus 4 equals 0. Okay, and you solve and you wind up getting cosine of x is equal to negative 1/2 and cosine of x equals 4/3. So this one's no solution because you can't have anything bigger than 1. And this one is, there are 2 answers for this one. If I leave it, it's in degrees, by the way, right? It shows right there. So cosine, the reference angle is going to be 60 degrees, and cosine's negative here and here. So it's 180 minus 60 is 120, and 180 plus that is 240. So those are your 2 answers. Okay. Next one is a little complicated because, in fact, we had this one. You saw this problem, I think, on your during the chapter and even in the review sheet. You don't want to square it here because if you square it here, it's crazy looking. So I'm going to move that cosine over. So I get square root of 3 sine of x equals negative cosine of x minus 1. And now I'm going to square both sides. Okay, so Microsoft Word dumped on me. But it's okay, as long as the video didn't dump on me, we are good to go because you did not hear me scream. So we are clear to go. So let's go back to 32. I would have been very unhappy if the video dumped. Okay, this is already 37 minutes, so I don't know what's going on. Well, hopefully it's good. Okay, let's keep going. So I'm going to move this over again. So sorry. So we got square root of 3 sine of x equals negative cosine of x minus 1. So I square both sides. And so we get 3 sine of x, sine squared of x, equals cosine squared of x minus 2 cosine of x plus 1. Okay, I think we're good with that. And the deal is that 3 sine squared of x, I'm going to change that into 1 minus cosine squared of x equals that, and then it's 3 minus 3 cosine squared of x equals that. So I'll write it out here again. And then I'm going to move everything over. So I'm going to, if I add 3, so I get 4, I'm going to write up here 4 cosine squared of x minus 2 cosine of x minus 2 equals 0. And then I'm going to factor out a 2, or just divide by 2. So I get 2 cosine squared of x minus cosine of x minus 1 equals 0. And if I factor that baby, I get 2 cosine of x minus 1 and cosine of x plus 1 equals 0. So I get cosine of x equals 1/2 and cosine of x equals negative 1. So I get, for this one, x is 60 degrees and 300. So I'm just going to let you guys should be able to do that. And then this one is x equals 180 degrees. Now remember, math fans, whenever you square it, which we did right here, you got to check for extraneous solutions. So it turns out that the 60 does not work when you plug it back in and do the original problem. Okay, you got to do the original problem. So that the answer is just 300 and 180. Okay? All right, let's keep going here. This one is a pretty mellow one, right? This is tangent of 4x, so I know I'm going to have 4 times the number of answers as usual. So I get tangent of 4x equals negative 1. And so basically 4x, you guys should remember, negative 1, we're in these 2 quadrants. So this is going to be 4x equals 135 and 4x is equal to 315. And then I'm going to add 360 to that. Oh, I guess it's in, it's in radians. I didn't even see that. Okay, so sorry. So that is 135, which is 3 pi over 4. And that's 7 pi over 4. So I'm going to add 2 pi to that. And then, so I'm going to add, I don't want to get through this video here, but I'm going to add 2 pi to that 4 times. And my last step with all, so I'm going to have basically 8 answers here. And the last step is I'm going to multiply everything by 1/4 to give me my 8 answers. So it's going to be 3 pi over 16, 7 pi over 16. I'm not reading them off because you can look at your solution and see what they are. But that's what you do. Okay? Let's keep going here. Always makes me nervous. I'm at 40 minutes now, so everyone remain calm. Okay, so the first thing I'm going to do with this, I'm going to just divide everything by 2. Just makes it nice. So tangent of 2x equals negative tangent of x. So double angle for tangent is 2 tangent of x over 1 minus tangent squared of x equals negative tangent of x. Okay, and then I'm going to move it to the other side. So I'm just going to, that becomes plus equals 0. I'm going to get a, what can I do with this one? I can factor out a tangent of x. I guess there's a few ways to do this one. But if I factor out a tangent of x, actually it kind of makes it nice. If I factor out tangent of x, I get tangent of x and then 2 over 1 minus tangent squared of x plus 1 equals 0. This actually makes it really easy to deal with now. Tangent of x, I could have gotten a common denominator if I wanted to. That would have worked as well. Okay. Anyway, tangent of x equals 0. And 2 over 1 minus tangent squared of x plus 1 equals 0. Am I going to do that one? Okay, it looks a little nasty. Anyway, this is going to be 0 and 180. It's in degrees, I think. Yeah, this one's in degrees. So 0, 180. And this one, if it's basically, let me write it over here, 2 over 1 minus tangent squared of x plus 1 equals 0, so that's going to equal negative 1. And then if I cross multiply, I get 1 minus tangent squared of x equals negative 2. I'll just do it that way. Okay, and then I'm going to move the 1 over, so I get negative tangent squared of x equals negative 3. Divide by negative 1, so tangent squared of x equals 3. Take the square root of both sides, so tangent of x equals plus or minus root 3. And that actually gives me, let me move it down a little bit, that gives me, this is not a 3-part, it's very sad. It's just going to be, reference angle is going to be 60 degrees, right? And so we're in all quadrants, so it's going to be 60, 120, 240, and 300. Those are your 6 answers for that problem. Kind of a complicated little problem, but that's what it is. Okay, whew, let's keep going here. I want to run out of, we're still good here. Okay, convert polar coordinate. Oh man, this is like old stuff. Do I really need to go over this? I guess I will. We're getting there. Almost there. Okay, convert polar coordinates to Cartesian coordinates. So just, this is easy. Just drawing a quick picture, I think is like easy. I think I'm looking at my key. I did it a different way back in the day. I don't know. But the first thing I would do, even to convert it, I would change this to 4 comma, and then I would add 180 to that. So 4 comma 300 degrees. I just think that's much easier to deal with because then you're down here and this is 4 and the reference angle is 60. Across from the 30 is 2, and across from the 60 is 2 root 3, and it's negative here, so that's your coordinate. It's 2 comma negative 2 root 3. Much easier when you draw a picture. Okay, so the next one is negative 512. So negative 512 is here, so negative 512, and then this is 13, and to figure out the angle, it's just tangent of theta. We'll get the reference angle, right? It's all you want to get the reference angle, so it's y over x. So it's 12 over 5. Do inverse tangent of that. Make sure your calculator's in degree mode. And we got theta is equal to 67 degrees roughly, and r is 13. So it's 13 comma 67 degrees, r comma theta. Okay. Convert that to rectangular form. It's an equation. We just took a test on that, so you guys remember multiply both sides by r. So it's r squared equals 2r cosine theta. That's x squared plus y squared equals 2x. And this is just completing the square, so I can move that over. So I get x squared minus 2x plus y squared equals 0. Half of that is -1, squared is 1, so it's x squared plus 1. But it's, well, here, let me just out of quickness. So it's x minus 1 squared plus y squared equals 1. Okay? So pretty easy. Find an equivalent equation. Now they're asking that x plus 3y equals 5 to convert that into polar. So of course x is r cosine of theta. So we have r cosine of theta plus 3 r sine of theta is equal to 5. I'm going to factor out an r. Okay, plus 3 sine theta equals 5, and then divide both sides by, I'm running out of room here, I'm sorry, divide by cosine of that. So basically you get r is equal to 5 over cosine theta plus 3 sine of theta. Okay, and that's kind of crazy look, but that's what it is. So that's obviously linear. Okay, next one, graph r is equal to 2 cosine of theta. You guys should recognize that as a cercle in French or a circle in English. So you pick a couple values, right? You pick 0, 90, 180, and 270. So picking 0, 2 times cosine of 0, cosine of 0 is 1. So it's times 2 is 2. So it's 2 comma 0 degrees. That's the first point. I pick a 90. Cosine of 90 is 0. Times 2 is 0. So it's 0 comma 90 degrees. Then it's 180. So cosine of 180 is -1. That gives you -2 comma 180. And then 270, again, that's 0 times 0, 0. So it's 0, 270. Okay. So we plot those points. So 2, 0 is 1, 2 right here, -2, 180, so you go to 180, which is to the left, but you go back, so we're actually on the same dot. 0, 90 is right here, and 0, oh, sorry, I don't know why I did that. It's 0, let me get rid of that. That's out of here, okay. So we're 0. So it's actually right here. So the circle looks like this. Right in that spot. Okay. All right. Still humming along here. Program hasn't died yet. That's good. Good sign. Right in polar form. So you guys know this is a complex number. So 8 minus 8i is going to be down here. And so it's 8 and 8 and 8 root 2. Of course, the reference angle is 45. So the angle around here is 315. So it's going to be 8 root 2 cis 315. Okay, it's polar form. Next few problems are really easy. This is just the product rule, product property, right? So you multiply the 2 times 8 is 16, and you add the angles, cis 120. And they actually write in standard form. That means you put it into a plus bi form, rectangular form, right? So 120 is here, reference angle is 60. So this is 16 here, and then across from the 30 is 8, and across from the 60 is 8 root 3. And this is a -8. So this is going to be -8 plus 8i root 3. Okay, that's good. And this is division, so z1 divided by z2, so it's basically 2 divided by 8 is 1/4. And 40 minus 80, remember it's top minus bottom, so 40 minus 80 is -40. So I told you this has got to be always between 0 and 360, so I'm going to add 360 coterminal. So you get 1/4 cis 320 degrees. And that is, you can't do anything with it because 40 degrees is not a friendly angle, so that's my answer. Okay. The next one is using de Moivre's theorem. So it's z2 cubed. So it's going to be 8 cis 80 cubed. And it's already in polar form, which is good because we need it in polar form. And so 8 cubed is 512, cis 240. and that's polar form. So we're done. Okay. The fourth roots of that means you're going to find 4 answers. Okay, and put it in polar form. Okay, so first thing you do is you're going to draw a triangle. So 8 plus 8, so it's 8, and then 8 root 3, and so this is 16. And across from the 8 root 3 is 30 or 60 degrees. Sorry. Okay, so in polar form it's 16 cis 60 degrees, and that's x to the 4th equals that. So it's x equals 16 to the 1/4, so that you're basically taking this to the 1/4 power. 16 to the 1/4 power is 2, and 1/4 is 60 is 15. So 6 is 15, and because there's 8 answers, it's 360 divided by 4. I say 8 answers, there are 4 answers, is 90 degrees. So I add 90 to that. So 2 cis 15, 2 cis 105, 2 cis 195, and 2 cis 285. Those are your multiple answers. Okay, we're getting there. Woo! 50 minutes. If it dies now, you will definitely hear a scream. Okay, so this is just a little vector one. This is, I don't really need to go over this one. 2 times that, 2 times u minus 3 times w. I mean, come on. Okay, just it's a vector, and it's -5 comma 45. That's like super easy. This one's a magnitude, so make sure you add the vectors together first, and if you add those, you get -14 comma 21, and then it's basically 14 squared plus 21 squared gives, and then the square root of that. So you get 25.24. That's easy, guys. Don't forget dot product. Please do not give me a vector. It's not multiplication. It's a dot product. So it's going to be u dot w is -10 times -5 is 50, and 24 times 1 is 24, so plus 24. So we have 74 as an answer for the dot product. Okay. Number 43. Okay, so this is a nice little bearing problem. Whoop, whoop, whoop. Starting at point A, ship sails 18.5 kilometers and 189. So it's kind of like this. So this is 189. And then turns the sails on a bearing of, so this is another bearing line here, touching this, 317. So this is going around. We do some colors here. So that's 317. And this is 40, so this one's 47.8, and this one is 18.5. And they want to know, find the distance, the ship, from the distance from the ship from point A. So this distance. Guys, this is really not difficult. Think about if that's 189, this angle then, right, is 180 minus that, so that's going to be 9 degrees. And then if that's 317, this angle right here is 360 minus that, which is 43 degrees. So then the total angle is 52 degrees, and that's why it's really a pretty easy problem. Because when you draw it, if I just draw the picture, 52 degrees, 47.8, 18.5, and then you're looking for x. So you're using law of cosines. So I guess I can write this out real quickly. It's easy. So x squared is equal to 47.8 squared plus 18.5 squared minus 2 times 47.8 and 18.5. Don't forget it's cosine of 52 degrees. Really important. Okay? And so you get, and don't forget to take the square root. So x comes out to be 39.22 kms, kerfometers. Okay? We're almost there. 44. Find the force necessary to move forward. Guys, I told you this problem's on there, so I'm just drawing this picture really quickly. And it's, here's the box on here, and it's, the weight of this is 43 pounds, and it's 21 degrees here. So if I draw the triangle correctly, this is also 21 degrees. And I'm looking for, this is 43 by the way, and I'm looking for the force. Find the force necessary, so I'm looking for this. So it's basically just sine. So sine of 21 degrees is equal to, we'll call that x. X over 43. So cross multiply, sine 47 or 43 sine of 21 x equals 15 pounds. Okay. Last group of problems is just some basic problems with angular and linear velocity. Remember, guys, a couple different things. Velocity is equal to omega r, or r omega, and r is equal to v over, so v is linear velocity, omega is angular velocity, and r is your radius. So r is equal to v over omega. So when I see 1500 revolutions per minute, I think of omega, but you have to put that into radians. That's important. So it's 30 feet per second. That's my velocity. So 30 feet per second divided by 1500 revolutions per minute. Okay, you can't use it, like, you have to actually convert it. So I'm going to rewrite it first. Excuse me, 30 feet per second times 1 minute per 1500 revolutions. Okay. Because again, we're trying to find the radius here. And so I need to convert couple different things here. Oh, by the way, it's in inches. So I got to convert that from feet to inches. I'm going to do that first. 1 foot is 12 inches. So the feet cancel. So now we have 30 minutes per revolution. We need minutes here. So times 60 seconds is 1 minute. So seconds and seconds are out, and minutes. So now we just have inches per revolution, and we say 1 revolution per 2 pi. It's got to be in radians. So the revolutions cancel. Has to be in radians, or has to be in radians. So now you look at your units left over. It's just inches, and that's perfect. So you multiply all that together, and you get 2.29 inches. Okay? My voice is getting a little hoarse here too. 46. Hey, my favorite number. It's my birthday. Okay. A jet is flying at an altitude of 30,000 feet from the ground. Observer sees it. So this is a sub 10 problem. Remember, using S equals R theta. Okay? And it asks you how long the jet is. Remember, S is your, if I would draw the picture here, S is your arc length. So that's how long the jet is. That's important. Radius is how far the jet is away. Got to know that. And theta, remember, is in radians. Super important. So I'm asking how long the jet is. So I'm asking for S. So S equals R. So 30,000 feet times theta, which is 1 degree, 15 minutes. And then you got to convert that into radians. So pi over 180. So S comes out to be 655 feet. It's a crazy number if you don't convert it to radians. I mean, the jet would be like a mile long, which means everyone's going to die because the plane's going to crash, and it's just brutal. Okay. 47. The radius of a circle is 20 inches. The measure of central angle intercepts the arc is 79 degrees. What is the length of that arc? So again, it's S equals R theta. So S equals R. So again, that's really easy. 20. And then theta is 79 degrees. Gosh, that's easy. So pi over 180. So you get 27.6 inches. Okay. So this is area. If you guys remember that little friendly formula, area is equal to 1/2 r squared theta. We did sectors, area of a sector. Central angle is 55 degrees. So area is equal to 1/2. Radius is 5. 55 degrees again. It's got to be in radians. So you get 12 centimeters squared. Okay. So that's the end of this sheet. Now, before I close this video, which again I'm taking a chance of it going too long and not being happy with me, is I want to do the one with the graphs. I could do that as a separate video. You know, I will do it as a separate video because otherwise I don't want this to die. All right, that's it. I hope you guys learned everything, and I hope you guys get an A+ in the final. You better get an A+. Domination, baby. Adios, math fans. Goodbye.